Hey everyone, welcome to Ethio-Hahu tutorial, where we make learning physics and mathematics fun and easy. Whether you are a high school or university student, you are in the right place. If you are ready to ace your exams, boost your grades, and fall in love with physics and mathematics, make sure to hit that subscribe button and ring the notification bell so you never miss an update. Having said this, let me go to freely falling bodies. Today we are going to see about freely falling bodies. What is a freely falling bodies? The motion of a body under the influence of the Earth's gravity is often called free fall. The motion of a particle under the influence of the Earth's gravitational field or gravitational force is known as free fall. A freely falling body is an object moving freely under gravitational field only, regardless of its initial motion. That means the only net force acting on a freely falling body is gravitational force. And this gravitational force always attracts objects towards the center of the Earth. Once a body is in free fall, the body has a downward acceleration equal to acceleration due to gravity. But to make things clear, let's separate upward motion and downward motion and see one by one. In the downward motion, the gravitational force is acting downward. Therefore, when objects fall from a certain elevated point, then the speed will increase. Whereas when an object is thrown vertically upward or upward, then due to the gravitational force acting downward, the velocity of the particle gets smaller and smaller as it moves higher and higher. Therefore, at some point above the surface of the Earth, the velocity of the particle becomes zero. This is due to the gravitational force acting downward, because the net force acting on a particle moving upward is downward, whereas the motion is upward. Since the force is opposite to that of the motion of the particle's velocity gets decreased and decreased. Whereas in the downward motion, the net force is acting vertically downward and the motion is vertically downward, so that the force and the motion are in the same direction and the velocity of the particle increases downward. Let's see equations of motion that governs a freely falling bodies. In downward motion, the displacement along the y-axis is equal to y0 minus v0 t minus half gt square. This means a particle is thrown vertically downward with an initial velocity v0. If the particle is thrown from a certain elevated point, x-axis, and if this y-axis and this x-axis is our reference point, origin. If the particle is thrown vertically downward from a certain elevated point above surface of the Earth, this is y0. Y is the vertical displacement of the particle at any instant of time. Say, when the particle reaches this point, this is y. That is the final position of the particle. This final position of the particle is equal to y0 minus v0 t minus half gt square. Because the motion is downward, the initial velocity of the particle is downward, it is negative, minus half times gt square. Again, acceleration due to gravity is downward, because last time we have seen about delta x is equal to v0 times t plus 1 over 2 a t square. This is displacement. If the displacement is along the y-axis, this is delta y. v0 y of t plus half times ay times t square. But all objects under free fall accelerate with acceleration due to gravity. A is equal to minus g or minus 9.8 meters per second square. Why negative? Because the acceleration is always vertically downward. That's why we use negative here. The final velocity is v is equal to minus v0 minus gt, and v square, the final velocity square, is equal to v0 square minus 2gy minus y0. Therefore, the position of the particle at any time t is y is equal to y0 minus v0 t plus minus half gt square, v is equal to minus v0 minus gt, and v square is equal to v0 square minus 2g into y minus y0. When we come to an upward motion, a particle may be thrown from the ground with an initial speed v0. This is the ground. Then it moves upward. If the particle was thrown from some points, some elevated points above the ground, if this is a table, from this table, if the particle is thrown vertically upward, the initial position of the particle is y0. And the final position of the particle when the particle reaches this point is y with respect to the origin. The particle may be thrown from the ground or from any point above surface of the ground. In this case, our reference is the ground. With respect to the ground, initially the particle is at y0 and finally the particle reaches y. Therefore, y is equal to y0 plus v0 t minus half gt square. Y minus because acceleration due to gravity is still downward, but the motion is upward. V is equal to v0 minus gt. As the particle moves higher and higher, the velocity of the particle gets smaller and smaller because from this we are using minus g times t. The particle gets smaller and smaller velocity. The final velocity square is equal to v initial square minus 2 times g into y minus y0. The difference between these equations of motion and these equations of motion are only the direction of motion. Here, the direction of motion is upward, whereas here, the direction of motion is downward. Having seen this, let's do example. A stone is thrown from the top of a building with an initial velocity of 50 meters per second upward. If the building is 50 meters high from the ground, find A, the time needed for the stone to strike the ground, and B, the velocity with which the stone strikes the ground. Assume the particle is thrown from this point vertically upward with an initial speed of v0 is equal to 15 meters per second. The building height is h is equal to 50 meters. Then the particle moves up and comes to the ground. How long does it take to strike the ground? A, y is equal to y0 plus v0 times t minus half gt square. If we take this is our reference point, from the reference point, y0 is 0, this is 0, but the stone falls down to the ground 50 meters below the reference point. Therefore, we use minus 50 here. This is equal to y minus because the particle moves below the reference point. That's why we use negative 50. It's equal to v0 is 50 meters per second upward, positive 15 meters per second minus 1 over 2 times 10 t square. This is equal to minus 50 is equal to 15 times t. Here we have t minus 5 t square. Let's bring minus 5 t square to the left. 5 t square. 15 t to the left. Minus 15 t minus 50 is equal to 0. If we divide both sides by 5, t square minus 3t minus 10 is equal to 0. Therefore, let's find t. We can find 4t using different methods. T square plus 2t minus 5t minus 10 is equal to 0. By factorizing this, minus 3t is 2t minus 5t. This is minus 3t. Take the first terms, t square plus 2t, taking t as a common factor, t plus 2. Minus, take minus 5 as a common factor, here again, t plus 2. This is equal to 0. T plus 2 into t minus 5 is equal to 0. T plus 2 is equal to 0 or t minus 5 is equal to 0. This implies t is equal to 5 seconds is the right answer because t plus 2 is equal to 0 means t is equal to negative 2, but t is equal to negative 2 is not True. We don't have negative time. Therefore, the time required to reach the ground is 5 seconds. B. The velocity with which the stone strikes the ground. B. V is equal to V naught minus GT. This is equal to V naught is 15 meter per second minus G is 10, use 10 or 9.8 times T is 5. This is equal to 15 meter per second minus 50 meter per second. This is equal to negative 35 meter per second. Why negative? Because when it hits the ground, the velocity is vertically downwards. That's why negative 35 meter per second. Exercise. A ball is thrown straight upward with a speed of V naught from a point h meter above the ground. Shows that the time taken for the ball to strike the ground is T is equal to V naught over G into 1 plus the square root of 1 plus 2G H over V naught square. Again, to do this, a ball is thrown upward with a speed V naught from a point h meter above the ground. Here is the ground, and the ball is thrown vertically upward from h meter above the ground. Then shows that the time taken for the ball to strike the ground is this one, because the ball is thrown vertically upward and returns to the ground. Again, y is equal to y naught plus v naught times t minus 1 over 2 gt square. Taking this our reference point, y is equal to minus h, because below the reference point the ball falls h meter, that is minus h, is equal to y naught is 0, because the ball is thrown from the reference point. Y naught is 0. V naught times t minus 1 over 2 gt square. Let's bring minus 1 over 2 gt square to the left and v naught t to the left. 1 over 2 gt square minus v naught times t minus h is equal to 0. Multiplying both sides by 2, g times t square minus 2 v naught t minus 2h is equal to 0. Now let's solve for t, because this is a quadratic equation of the form ax square plus bx plus c is equal to 0. And the solution of this quadratic equation is x is equal to minus b plus or minus the square root of b square minus 4ac over 2a. Using this, a is g, t is x, b is minus 2 v naught, and c is minus 2h. Thus, t is equal to minus b minus minus plus 2 v naught plus or minus the square root of minus 2 v naught square minus 4 into a is g, c is minus 2h divided by 2 times a is g. This is equal to twice of v naught plus or minus the square root of minus 2 v naught square is 4 v naught square minus 4g minus 2h is plus 8gh divided by 2g. Now, this is equal to twice of v naught plus or minus, take 4 v naught square as common, 4 v naught square into 1 plus 2gh over v naught square under radical divided by 2g. This is equal to 2 v naught plus or minus the square root of 4 v naught is 2 v naught into the square root of 1 plus 2 times gh over v naught square over 2g. As you can see, the terms under radical is greater than 1. and this is greater than 1. This greater than 1 times 2v0 is greater than 2v0. Therefore, this minus sign is ignored. Therefore, t is equal to twice of v0 is common. 1 plus the square root of 1 plus 2gh over v0 square over 2g. 2 goes with 2. v0 over g into 1 plus the square root of 1 plus 2gh over v0 square. That is done. And this is all about today. Next, we'll see another topic, and until then, have a nice time.